Okay, so my presentation's over gifted and talented students. We all probably know a little bit about that. So does anybody want to tell me what some of the characteristics are of gifted and talented students? Kevin?
They have, well, I guess it's exceptional gifts, maybe a specific area, maybe math or science. They're kind of above their classmates.
Yeah, that's true. And anything about the way they learn, maybe?
They generally get things more quickly than their peers, and so they get bored easily.
Yeah, that's true. Brandon?
It could be like the video we saw last night, that the boy that he didn't understand the different. He couldn't read, but he had amazing memorization skills and he excelled in every other aspect. But he couldn't read or understand the words, so that could be kind of a way, I guess.
Mm-hmm. Okay. Well, according to the book, characteristics of gifted and talented students are these. They do learn more quickly and independently than their peers. They're better teaching themselves. They do have advanced language skills and reading skills in general. They have good metacognitive strategies and higher motivation on the challenging tasks and less on the easy ones, and they tend to have high personal standards of achievement. And like Kevin said, they don't have to just be smart or something in everything. They can be talented in music or a specific subject or something like that. And the problem in schools today is that they aren't equipped to teach the gifted students as well. So students don't feel like they reach their full potential, and they are less motivated to do the regular tasks and become underachievers. And then so it seems like they're not gifted, and they're actually less gifted than other students. Teachers or the schools use standardized tests to find out about that, which isn't very good, because as we find out in the GSKyTeach schools, a lot of the schools are said to be in high need, but when you look at the SAT scores or the ACT scores, they're actually doing pretty well. Oh, and females and minorities are generally underrepresented in the gifted and talented area, so that's something to watch out for. The two methods of teaching gifted and talented students in the book are enrichment and acceleration. Enrichment is alternate instruction. Some criticisms of that is that enrichment just turns into busy work, though. It's not actually advancing the learning. Acceleration, they move through the curriculum quickly, but for a lot of students, they don't have good social skills, and moving into classrooms with older students, it kind of stunts their growth in that area. So one of the research articles I looked at was about model eliciting activities. In the article, they talked about ways to identify gifted students using this, but the models themselves are actually good methods for teaching anybody. To know how to use this, you have to look at the students' creativity in math, where they find a non-standard solution to a problem that they could have used a standard solution on. So they require creative, practical, and analytical abilities, and they have to look at things more in the abstract to get all the way through the problem. Description of a model eliciting activity is that it includes a passage. It's usually represented like a newspaper article. It's about one page, and at the end, it asks you, like you're working for a client and you have to figure out how to meet the demand that the client has. One of the examples was in our How to Learn book, I think. They said something about boats, like how to do the timing for sending different people off in boats and stuff. That was a good example of one of those. There's a readiness question section that makes sure everybody knows how to do the problem and has all the information interpreted correctly. So that's a good evaluation point to see that students are on track. And there's usually a data section that you use for the readiness questions and in the actual problem. And the problem is usually complex. You have to build a model, and so the model is related to the real world, and so it's more meaningful to students, and it's challenging. One of the problems with this is that you have to generally get the problems off the internet because it takes a lot of training to be able to make up your own problems. And it has to include a model, and they're realistic. Self-assessment is a big part of this. The student has to assess whether the model they've built is actually a good model. And they work in groups, so all the students assess whether they're actually answering the question with their model. And they have to document their processes on how they did it, which also contributes to self-regulation and self-assessment and metacognition, since they have to think about what they did. Reusability. Other students have to be, well, actually that's the prototype. They have to be able to use their model for different things, and the other people have to know what they did to get their model. And effective prototype means that they can use them for slightly different questions. So that has to do with transferability that we study too. They have to be able to use the knowledge in other places than just the one set of problems. Okay. The next article I looked at was actually a case study where the students are mixed in. It's not just the gifted students, so this also applies to everybody. This took place in a geometry class in the 9th grade. And this person used a differentiation style with the goals of greater depth and complexity of the content, discovery and exploration. They used open-ended problems, and they also included interdisciplinary connections. The three methods they used were extension, which and one of the contexts they used it in was congruency of triangles. While the entire class worked on that, any number of students could work together on a separate thing. And the question involved was asking for two systems to describe and sort quadrilaterals. So students had to test their systems to make sure all the quadrilaterals fit in one or the other. And they collaborated with each other, and they present their findings. Now, they ended up being two teams, and the teams would try and knock the other one's theories down. So they were looking for errors in the other presentation. So they got excited about it and were more motivated. It also happened in the open-ended question, which was about the minimum information necessary to prove that two triangles are congruent. And then when they were still a little ahead of the class, at the end of that, they got an extra question, so you can easily modify things to fit with the flow of your classroom. I think they found something that you only learn in trigonometry, so they really were figuring things out well on their own. And the last one is self-selection of problems. That one's pretty self-explanatory. You pick out different things that you want to do. And some of the questions were provided by the teacher, like describing the Pythagorean theorem and some different ways to prove it, which also led to a question about the difference between a proof and a demonstration. And the interdisciplinary concept was the history of different things like the Pythagorean theorem. Any questions? Yes.
What are some specific strategies that math and science teachers can use to successfully work with students who are gifted and talented to meet their needs?
You say that again?
What are some specific strategies or instructional practices, beyond the two that you brought in, that teachers could use, actually use in the classroom when working with students who are gifted and talented, knowing that we're not going to be able to ship them off into other classrooms? I mean, you're going to have students in your classroom that are going to fall on either end of the continuum with high confidence. So what kinds of things can you do to work with students like that to meet their needs? That's my question on the table.
Okay. Working with them individually on a small project or something, having them help their peers might advance their understanding. They might be able to explain how they learn better, and so understand their process.
I was thinking maybe you could give them kind of some extra work, take the concept maybe a step further than the other students and maybe have them explain that to the class, how they did it.
Okay, so you're kind of suggesting, the word extra is always taboo, right? Think about you as a student. If you are getting your work done theoretically and you were given more to do, right? So you're suggesting to go further in depth, like give the student opportunities to go more in depth with the topic and then share what they've learned.
Yeah, and that would help the other students in the class as well.
Okay, what else?
I had a student, when I was teaching at ETSU, they were an English major and a science major, and so I would ask them to write poems about what they learned in class and send it to me in an email, so that way I could try and tie in the two subjects. And he was also really good to answer like all the questions in class, so it was trying to find a way to tie in what they enjoyed outside of class with what they enjoyed in class. And I didn't make him do it, but I asked him if he wanted to send it to me. I would read them, coaching them for me, so it was cool.
Okay. Great, I'll give you a minute to complete your, and then we'll talk.